Hello, ladies and gentlemen. Welcome to Math 20-2, Chapter 5, Lesson 3, Standard Deviation. The goal today is to be able to determine the standard deviation and use it to solve problems and make decisions. Solve problems and make decisions. Okay, so we're going to explain, using examples, the meaning of standard deviation. Standard deviation. We're going to calculate, using technology, the population standard deviation of a data set. We're going to explain, using examples representing multiple perspectives, the applications of standard deviation for making decisions in situations such as warranties, insurance, or opinion polls. Warranties is the missing word. And we're going to solve a contextual problem that involves the interpretation of standard deviation. Now you're going, what the hell? Let's just do an example. So, here are some players: Anita, Patricia, Morgan, Paige, and Star. Their field goal percentage in the last 10 basketball games. Field goal. Could be football games. Anyway, so Anita, 36%, 41%, 43, 39, 45, 27, 40, 37, 31, 28. Patricia, blah, 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 blah. Bunch of numbers. So the coach needs to decide who's the most valuable player. Who would you choose and why? Those of you that know me are instantly blurting, who brings the most Kit Kats? Well, let's do this mathematically. Now, standard deviation is a measure of how far apart the data is scattered. Scattered. A lower deviation means more consistency. Now the symbol is this sigma thing. Now depending on the font, it's an O with a tail on it, Greek S. Those of you in my class know that snobs speak Latin, snobby snobs speak Greek. So anyway, so here we have two groups, each with an average 52, but a standard deviation different. This standard deviation is 6. Actually, let me color code this. That's a standard deviation of 6. And this is a standard deviation of 12. Now, of course, we're going to be doing some math on this and make this orange. So the bigger the standard deviation, the wider or more spread out the data is. So you'll notice the smaller the standard deviation, the more consistent you are. Okay, that's important to note here. Now, calculating this. If you remember to bring your graphing calculator like I told you to, this is easy. Calculate the mean and the standard deviation of each player. So, what do? Grab your graphing calculator. Clear. Oh, you poopy head, stop that. Now, careful, you go statistics. So on your graphing calculator, you turn it on. Stat button, middle top, you get edit, calculate test. You hit enter when you're on edit, and you've got a list. So you go up, and you put in that list. Now, here, I'm going to do Anna's. Now, she is 36, enter, 41, enter, 43, enter, 39, enter, 45, enter, 27, enter, 40, enter, 37, enter, 31, oh, you poopy head, 40, enter, 37, enter, 31, 31, enter, and 28, enter, 28. There we go. So note, it's really easy to make a mistake putting your numbers in your graphing calculator, so don't do that. Embarrassing when you do that in front of people on video. So we just edit. Now we enter the list, and we go. We've entered the list here. We go statistics again. We scroll over to where it says calculate. Now we're doing one variable statistics here. Enter. Now, depending on which version of TI you're using, you might have to enter twice, you might have to enter 3 times. Just be careful. Don't just press enter forever because you go enter. It's going list L1, frequency, you skip, calculate, enter, and there we go. It spit out a bunch of numbers for us. Now, I just typed it in, and I've got my mean. Now this is for Alicia. Sorry, Anna. Alicia, forgive me. Anna. She has an average, the mean of 36.7. The sum of the list, 367, so you add all the goals together. Now, there's some stuff here we do in statistics first year university. We skip that. So the sum of the x squared, Sx, we skip, but notice this one here, sigma. And I can't write on the calculator, of course. That is the standard deviation, 5.88. The number of items in the list is 10. And then I scroll down. Min x, the smallest x, is 27. Q1 don't worry about. Q3 don't worry about. The median, they just gave you the median number, 38. And the max is 45. Right? Q1 and Q3, that's statistical stuff we'll deal with later. So, Anna, the mean, 36.7, and the standard deviation is 5.88. Okay? So Patricia, Morgan, Paige, and Star. We do the same thing to find the averages for all of these ladies. All right? Now, I'm going to do Patricia with you, then I'm going to have you do Morgan, Paige, and Star. So let's grab Mr. Calculator. So for Patricia, going back here, punching in Patricia's numbers. So statistics, edit. Now you notice I've already got Anna's numbers here. What I suggest you do is scroll up, goes L1, clear, enter, erases the list. Or you can go delete, 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 delete in the list, whatever floats your boat. 36, 39, 36, 38, 35, 37, 35, 36, 38, 34. Now, statistics, calculate, one variable statistics, frequency, 36.4, standard deviation of 1.5. Now, Patricia is standard deviation 1.5. All right, now, I'm going to pause the recording. I want you guys to do this for Morgan, Paige, and Star. Now, honestly, you might be a little fuzzy on this, so I'm going to do Morgan with you, then I'm going to pause it, and you're going to do Paige and Star, and we're going to look at the numbers. Hint, when you do this, scroll down, look at the minimum value, 34, the maximum value, 39, and end the number of values you put in. Because there's supposed to be 10 values here. If there's only 9, you made a boo-boo. And if you look at your minimum, it's like 3 instead of 34. Well, you forgot to put in the 4 for the 34. Or like if you got a maximum like 4039, you've got to hit enter, and it's going 4039 instead of 40 and 39 is separate separate data point. Yeah. All right. Anyway, so let's get this done. Statistics. Edit. Now, as I said before, you can just go clear, 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 clear. Clear, 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 clear. Sorry, delete. Forgive me. Delete, 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 delete. My apologies. On this version, I have to hit delete instead of clear. easier to scroll up and clear the whole list, but whatever. So quickly, I'm going to do this. So Morgan is 34, 41, 36, 37, 48, 19, 19, 33, 43, 21, 44. Statistics, calculate, yes, 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 yes. 35.6, now actually double check, go down. N is 10, so we put in 10 numbers. The minimum is 19. It was a bad day for her. The best day was 43. So this average is, let me see, scrolling up, 35.6. And the standard deviation is 9.5. Right? Now, I'm going to pause the recording. I want you to do page and star. And when we come back, we'll talk about who's the better and why. All right? So you go do page and star, come back and tell me the mean and the standard deviation. All right, good luck. Okay, welcome back. Now, for page, I got an average of 33.9 and a standard deviation of 0.83, and star was 35.8 with a standard deviation of 3.42. Now, who's the most valuable player? Here we're going to argue about it. So you have to choose a number, choose a player, and justify your answer. Now, offhand, there's two ways to think about this. Who's the best? Well, Morgan and Anna. Well, sorry, let me phrase that. Notice the mean or the average is pretty much the same. So the only real difference is the standard deviation. So how spread out or how distributed the data is. Now, or scattered. I'll say for Morgan is the largest standard deviation. So that means on a good day, she's not 35, she's 35 plus 9, which is like 44. On a bad day, she's 35 minus 9, like 25. So on a good day, she's great. On a bad day, she's not great. She's actually not good at all. Same thing for Anna. On a good day, she can get like 6 more. On a bad day, she gets like 42 or 43. On a bad day, she's 30. So the most valuable player, I would tend to think, would be the most consistent. So I think Anna and Morgan are too inconsistent. And if we're looking at consistency, star is good, but she's plus or minus. Now, here it comes down to Patricia and Paige. Now, personal opinion. Okay, now Patricia, 36.4 with a standard deviation of 1.5, which means there's not a lot of scattered. She's consistently good. Paige, on the other hand, has a much smaller deviation, but her average or mean is a little smaller. So Paige is consistently around 34 points a game. Patricia is like 35 to 38 a game. So Paige is most consistent. Patricia is a smidge better. So I would say offhand Patricia. But we can argue about that. This is one of those questions where you justify your answer. It's not the answer you choose, it's how you justify it. And yes, someone could say Morgan, because on a good day she's good. On a bad day she blows chunks. I shouldn't say that about a player. On a bad day she has a very bad day compared to everybody else. Not consistent because of the large standard deviation. Now this video is getting long, so I'm going to pause it here and then we're going to go on and do some more examples. But this is how we calculate a standard deviation. All right? Good luck.